The next company to present here is Phoenix Biopower. They have innovated and developed a platform, a scalable, cost-effective technology, that enables the doubling of electrical efficiency from biomass. And with us here we have Henrik Borge, CEO. Welcome on stage, Henrik.
Hi, thank you all for having me here tonight or today. I will first start with a little film that presents us and the company just briefly.
Today, the majority of world production of electricity is generated from fossil fuels, mainly from coal. To reach the 1.5-degree target, the fossil fuels have to be phased out. At the same time, energy demand is expected to more than double by 2050. That means a significant increase of renewable energy. In addition to this, negative emission technologies like CCS will be needed to reach the 1.5-degree target. Solar and wind power are expected to make up a large part of renewable energy. Because these sources depend on the weather, availability cannot be planned. Therefore, a plannable renewable power source is preferred. One of these sources is high-efficiency biopower. Traditional biopower basically works like an advanced steam engine. The efficiency is typically 25 to 30%. With the biomass-fired top cycle, efficiency can be doubled by 50 to 60%. This is how it is done. Biomass is loaded and pressurized before being fed into the gasifier. The biomass is heated up to around 900 degrees Celsius with hot sand to gasify the biomass. The gas is separated from eventual carryover particles from the gasification. The gas is cooled down and then filtered to take out the last harmful particles and pollutants. The gas is injected into the gas turbine. Mixed with air, it is combusted, expands, and passes through the turbine, making it spin and converts the chemical energy into kinetic energy. The kinetic energy is converted into electricity by the generator. The heat of the exhaust gases is used to generate steam. Steam is used in several parts of the process. Steam is used to pressurize the biomass. Steam is used in the gasification process. Steam is also used to cool the gas. Air from the gas turbine is used in the gasification. The waste heat of the exhaust gas is used for district heating. In addition to the biomass-fired top cycle technology being efficient and profitable, it is also plannable. Power when you need it, where you need it. Scalable. Possible to adapt to a global market. Local. Supplies heat to the surrounding area. Circular. Locally sourced waste from forest and agricultural industries is used as fuel.
Okay. Help here, please. So, when we started developing this technology, we initially saw that this is going to have a global application as we are addressing a global problem. And looking at global power generation today, we see that about 2/3 of power generated today is fossil, primarily from coal. You'll just have to excuse me that the presentation is in Swedish. Anyway, in order for us to reach the 1.5-degree targets of the Paris Climate Accord, not only do we have to phase out fossil, but we also have to almost double the generation of renewable power. So if we see that to meet the doubling, but also the phase out of fossil, we need to add roughly about 1,000 terawatt hours of power every year from now till 2050. Now that's a big number, but what is 1,000 terawatt hours? Well, it's basically 7 Sweden or 1 US every third year. So that gives you a little bit of a perspective of the challenge that we are facing globally in terms of this energy transition. Primarily, most of this renewable energy will be solar and wind. These are fantastic technologies. I myself has worked with solar energy. Actually, one of the companies presenting here today, Soltec Energy. Today, it represents a little under 10% of power generated today. Being fantastic, they also come with some drawbacks. They are intermittent. They're not plannable. So that will result in increased volatility in production. With the crowding out of plannable power, it will also result in capacity issues. And all these things result into massive needs in grid infrastructure and storage investment needs. And this has sort of, if you want to boil down it to a more local view in terms of Sweden, these are some of the headlines that we've seen that industries can't establish. We see investors fleeing certain regions with capacity shortage issues all over the place. We also see, and this is primarily from Stockholm and southwards, and we get price differences between northern and southern Sweden. And actually, lately on the public television, they say that we shouldn't use our vacuum cleaners when it's really cold. Now, these are not really signals to me that this is a top-of-the-line industrial country. These are effects that we shouldn't be seeing in a country like Sweden. So our proposition to this is renewable power on demand. Power which is plannable, scalable, and sustainable. So, as was described in the film earlier, we are introducing the BTC, which is a new power cycle. We're basically using the same fuels as currently being used in the combined heat and power industry and utilities, i.e. Forest residues and agricultural wastes and so on. So it's a high pressure process operating at 40 bar and up. So first we have a pressurization step because it's not a pumpable fuel. You need to batch-wise pressurize it. Then we feed it into a gasifier. We heat up the temperatures to around 900 degrees. We form a gas. We clean up the gas from ashes and pollutants and then feed it into a combustion chamber, which we have placed in a gas turbine. The gas turbine drives the generator to generate power. At the back end of this gas turbine, we then put a steam generator to recover the heat energy of the exhaust gases. Now, that steam is used as a medium to pressurize. We use it as a tool in gasification and gas cleanup, but also as volume, because in a traditional gas turbine, about half of air compressed is not used for combustion. It's volume and cooling. So if we take away that air and replace it with steam, then I have 50% steam in the combustion chamber, but I can also use steam for cooling of gas turbine components. That means I can use a smaller compressor. And instead of compressing air that I don't need for combustion, I can use that energy to drive the generator. So now we have, and then we also have the steam working as a heat carrier throughout the fuel conversion process. Now we have three key items that will raise our efficiency from the typical 30 to upwards of 60. Is we're going from steam turbine to gas turbine, we are using a smaller compressor, and we're recycling waste heat from the fuel conversion. We stack those on top of each other, and that's how we reach our high efficiency ratios. We have an accelerated development program going on. We have so far invested around 5 million euros in our development. Our primary sponsors and funders is the Swedish Energy Agency, but we have also recently received funding from both Eurostars and Horizon 2020. We are also cooperating with InnoEnergy, who is our largest external investor, which is a pan-European investor in primarily energy technologies. We also collaborate with Akademiska Hus, a large property company in Sweden, for our facilities, but also we have a number of small shareholders. We have what I amicably say is the Stockholm's most beautiful building. It's a closed-down coal-fired power plant at at the center of KTH campus, which is basically central Stockholm. This is an enabler for us to drive our technology forward in an environment which is ideally suited for our purposes. And the fact that it's about 200 meters away from a subway station doesn't hurt. So, and also we work with a number of resources because we cannot do this ourselves. We work with the Technical University of Berlin for gas turbine combustion. We work with KTH on gasification and some gas turbine work. We work with RISE, Infosys, some competence centers within gasification and materials, but also with Lund University on turbine. We raised some 3 million or 0.3 million euros in venture capital this summer by way of a Corona emergency program by InnoEnergy. We secured 1.3 million euros in public funding this summer from the Energy Agency and from Eurostars. And just before Christmas, we secured another 1.2 million euros in funding from a Horizon 2020 program. Our roadmap in terms of our base scenarios, we just about a year ago we completed our feasibility phase, where we basically established our reference group. We did our initial prototyping, testing, and plant simulations. We are now in what we call our validation phase, where is basically we're looking towards scale up, more integrated tests, and at the end of this period we're looking to erect a pilot plant at a 1/10 scale, where we'll be doing industrially relevant testing, where subsystems at full scale. And at the back end of this phase, we are expecting to get a first conditional order for our demo unit to launch our industrialization towards a full-scale demo unit at 25 to 30 megawatt electric in terms of capacity. That is basically a truckload of fuel every hour, if you want to get some sort of reference picture if you're not in the business. And on the back end of the commissioning of this plant, which we foresee to be somewhere around 2028, we then see upscale in terms of units, applications, but also in size. Just to show you some of the development projects that we're running on currently, we have one called Scarlet, which is basically an atmospheric gasifier, where we're going to be testing different kinds of fuel under the environments that we work with and the conditions that we want to do, but not pressurized, but atmospheric. We have another project we call PAX, which is basically our combustion development project, where we have one combustion chamber for a gas turbine that can operate with a various number of fuels, i.e. Natural gas, 100% hydrogen, 100% biosyn gas, or other gaseous fuels. And the reason why we can achieve this vast flexibility is the fact that we have roughly 50% steam in combustion chamber, making it very good for the very high reactive fuels such as hydrogen. We also have a project which we will be launching here before summer called Humphrey. Don't ask where these names come from. It's basically a pressurized rig to simulate the hydrodynamics of how the particles behave under pressure, because as you go up in pressure towards 40 bars and above, the density of the gases change, and that affects particle differently than they do in atmospheric conditions, and we need to find that out. Just as a reference point, the little hut there is basically the same as the cabins you see at construction sites, and the height is around 15 meters. These projects, together with other projects that we're running, we have around 10 in parallel, will lead us to the pilot plant, which I mentioned before. And the plan is to commission that at around 2024. And there you have a truck as a reference to see just kind of scale we're talking about for this project. We have a quite good network and a number of partners. We have a reference group with some very notable companies and organizations here in Sweden. I see Fabian is here as one of the representatives from Stockholm Exergi, who is a Stockholm and Fortum-owned utility. We have Tekniska Verken, another municipal utility. Svenska Kraftnät is the Swedish TSO. Sveaskog is Sweden's largest forestry company, and SSAB, Scandinavia's former or premier steel manufacturer, and also one of the drivers between the hybrid project for fossil-free steel. During this Corona year, which has been strange, in lack of another word, we have actually been successful in recruiting international development partners, and one of those is this company called Zorya Mashprojekt. It's a Ukrainian gas turbine manufacturer that is primarily started with supplying the Soviet and Russian military forces and Marine and Navy with gas turbines, but they have also moved towards industrial applications, and they do have a line of high steam injected gas turbines. So our top cycle technology with our ultra wet combustion system is familiar territory with them. Between May and December last year, we conducted call it a pre-feasibility study with them, where we looked at conditions on how do we develop a machine together. This has now led to that we will be launching a pre-study together with them to form a decision basis by end of this year in terms of developing a gas turbine. We also managed to get a EU utility working primarily within biomass at a 25 megawatt scale. We also recruited another European biopower actor working on a very large application together with CCS for CO2 negative biopower. We're working with Somas, a leading Swedish valve supplier for the pulp and paper industry. And we have a number of other discussions going on. Our business model is that we will be supplying a plant to the end user, i.e. a utility, together with our partners, gas turbine, EPC, etc. And thereby we get what we call hardware revenues in terms of installed capacity on a unit basis. But we also see there's room for a royalty revenue stream, so we get a dual revenue stream model where we can get both on the plant and on the production end. This is the founding quartet with Michael Bartlett leading the technology, Oliver leading our combustion, and Hans-Erik is the original inventor. We have a reputable board led by Mr. Stefan Jakelius, and with Katarina Lagerstam from Banking and Finance, Birgitta Resvik with Public Affairs from Svenskt Näringsliv, I don't know the English name, but also from Fortum, and Ola Johansson, who has run the gas turbine business in England for Siemens. Impact. This is a very important driver for us. We had the UN Sustainable Development Solutions Network look at our technology and map them against the Sustainable Development Goals by UN. And they say we have direct impact on 7 of the global goals and indirect on 6. So that means we cover directly or indirectly 13 out of the 17 global goals, which we find is extremely honoring and motivating. We are currently doing a share issue where we're looking to raise upwards of 23.8 million Swedish kroner. The share issue is currently going on now. We're closing on Monday, the 22nd, and if you want to have more details on that, please reach out to me. Thank you. I'll be glad to take your questions.
Yes, Henrik, thank you for your presentation. I have an initial question. It's about the uniqueness of your technology. What competition do you have globally, and how unique is your solution?
Well, uniqueness from a technology perspective, there is one prototype plant that was erected in the 90s called the Renewables project, which is neighboring but still quite far away. But in terms of that, we see biomass integrated with gas turbine technology is not a commercial product. It doesn't exist that we know of. But then if you're looking at competition, you can also look at, okay, what the product that we're offering, it's electricity and heat. There are a number of technologies out there. I mean, the steam cycle, which is known technology, that is obviously one. Combined cycle, natural gas and CCS, that is another competitor, of course. But if you're looking at purely plannable renewable power at the scale that we're talking about, we have failed to find many out there.
Speaking of biomass, we know that there is an exceptionally high demand for biomass in the future. What kind of biomass are you primarily putting into your system?
We're looking uniquely at waste streams, the ones that the part of the tree or the crop that cannot be used for higher purposes. I mean, if you take a traditional average tree in Sweden, when you chop it down, A quarter turns into a wooden product, a quarter turns into pulp and paper, a quarter turns into fibers and biochemistry, and the last quarter is just waste. Cannot be used for
And that's
higher
where you
purposes.
come in.
And that's where we come in. And if you want to build houses out of tree, or you want to make shirts out of wooden fibers, you will have this 25% of waste. So we use that to replace fossil. That's what we think. And as other businesses start moving into this waste stream, well, if they go low, we need to go lower and find other streams that we can handle. But that's part of our very long-term development roadmap.
And part of the circular economy.
Absolutely.
Well, thank you very much, Henrik Wåge.
Thanks
Best
for
of
having
luck.
me.
Thank you.